haven't I passed something around and had you guys look at this before? The dial caliper. You know, if you are thinking about some sort of engineering technology trade or something like that, you may want to learn to read this, and I will make sure when we've got them in the back, so if you want to try to measure it and see if you agree, I would go for it. I'm getting a diameter of 2.072 centimeters. Now hang on. 2.072 centimeters. How many meters is that?
0.02.
Right. So you want, notice it says 4 sig figs. So you want 0.02072 meters. Okay, now what's the radius then?
Half of that.
Half that, right? So what is that?
.01036.
Yep, I agree with that. 0.01036. Okay, now, have you heard this term before, the cross-sectional area, or the area of cross-section? It just means the area of the circle, the area of the circular footprint of it, okay? So what's the area of a circle? Pi r squared. So the area is pi r squared. Oh, I might even have that written in the lab. So it's 3.14159 if you want it, times whatever we just said, 0.01036. I'm doing it in meters. 036, is that right? Okay, thank you. Now, the numbers are going to be so small, you're definitely going to want to use some scientific notation here. And I think I might have left my calculator at home. Wow. Do not like to be without. Oh, yes. How many minutes do we have?
6.
Okay. Okay, 4.072, that's 4 significant figures, times 10 to the negative 3 square meters. So that's what's going in A. And then we're going to calculate the submerged volume for the first lowering. Hang on, let me write this. 4.072 times 10 to the negative 3. By the way, in Logger Pro, if you want to enter the numbers in scientific notation, you use that E notation. But did I just do it wrong?
Yeah, we got that. I got 3.37 times 10 to the negative 4.
Oh, yeah, you know what? Okay. I think I, garbage in, garbage out. I put the wrong number in. I put .036. So I totally, okay, so tell me what it is. I'm glad you guys are checking on me.
It's 3.3718.
3.3788, did you say?
1 or 9, 1 9 if you round up.
Okay, so I'll just do 2. Can I do 2?
Yeah.
3.372 times 10 to the negative 4. Thank you. I am so sorry about that. Okay, now here's the deal. Do you know what the volume of a cylinder is? Do you remember how to find that? Did somebody teach you that sometime? Okay, so I always, the way I always think about it is it's like stacking coins. So it's the area of the circle times the height of the cylinder. So the part for the volume of the cylinder, do I ask for the total volume of the cylinder, or do I just ask for submerged volume when the height's 0.01? So it's going to be V submerged 0.01. It's going to be the area times the height. So for this one, it's going to be 3.372 times 10 to the negative 4 times 0.01. So that's just going to be to the negative 6. Very good. Times 10 to the negative 6. Now, cubic meters. And that's a column in here, submerged volume. So your first submerged volume is 0 because you don't have it submerged at all. And then for the next one, it's going to be 3.372 e negative 6. So times 10 to the negative 6. And then for 0.02, it's just going to be 3.372 times 10 to the negative 4 times 0.02. And then times 0.03, and so forth, all the way down. 2 minutes? So, I don't think I need to do that with you. You guys can fill that second column out, right? Submerged volume. It's going to be times 10 to the negative 6 for a while, and then I think you'll have a couple at the end that are 10 to the negative 5. All right? And just remember, when you're entering the numbers in Logger Pro, use the E notation. Now, what you're going to do is make a graph on Logger Pro, and you can actually put both graphs on the same grid if you want. You're going to make a graph of submerged volume in cubic meters on the x-axis, and on the y-axis, apparent weight. So as you increase the volume that's submerged, you're going to decrease the weight. So you're going to end up with something like this. Here's the deal. Do a best fit line, and you're going to have 2 of them, okay? You'll have a line for alcohol and a line for water. The best fit line should have a slope that's equal to the weight density of the liquid, whatever the liquid is. The weight density is the density, rho, times G. So rho of water is 1,000 kilograms per cubic meter. So that's a metric ton per cubic meter. And do I have the weight density or the mass density of alcohol in here? Oh, I'm hoping I do. I think I do, but I can't find it. 9.8 times 787. 787 is the mass density of alcohol. Okay, so here's the deal, and we probably are already out of time on the video.
You want me to stop?
No, I'm just going to say real fast. Often students get really nice straight lines, but not the best numbers. So you're probably going to have, just get ready for a high % difference on this one, okay? But it's okay, because I think the force probes are just not